Thank you. Normally, basically, I kind of jog on stage, but I was trying to dance along with Stephen earlier. I think I pulled a muscle. That's it. So, if I hobble around the stage, or if I stay over here, that's why. That's it. I'm essentially crippled from the Dancing Queen. Now, my name is Matthew Griffin, so I'm the CEO and founder of the 311 Institute, World Futures Forum, and Exponential University. I look up to 50 years out, and I help companies build the future. Now, when we have a look at the future, it's increasingly complex. It's increasingly difficult for us to see what it could look like, let alone what it will look like, and then how we actually prepare ourselves and our organizations for whatever it happens to be. Now, in this particular presentation, I've sort of titled this The Future of Healthcare and Longevity, but I'm also going to be covering health spans. Because let's face it, it's all very well actually living a long life, but if you actually live 40 years in a care home, let's see, we talk about the quality of life. So I'm going to be looking at how we actually increase health spans along with longevity and other things. Now, this is my agenda. So we're going to be covering Embrace Your Power, which is much more basically about you as individuals. The automation myth, because there's a lot of myths about automation. A futures mindset, and then living beyond 100. Now, when we have a look at the future, basically, it's inevitable that a lot of people talk about it in this term, VUCA. Volatile, uncertain, complex, and ambiguous. But over in Hollywood, film producers, basically like Chris Nolan, have been adding the max to the back of it, where the future is massive, accelerating, and exponential. And I think, when we actually have a look at some of the artificial intelligence developments that we've seen recently, we can see how it's becoming more exponential and how change happens in weeks or months, not years or decades like it used to be. And this is kind of the challenge that we're all trying to actually cope with. Now, as part of trying to sort of figure out what the future looks like, the future is essentially a little bit like your own ICT systems, millions of data points. And we've got lots of different landmarks that are the future, different trends, different technologies, different innovations and breakthroughs, but we don't really understand how these landmarks fit onto a map. And so this is sort of where the challenge of trying to piece together what the future looks like so that we can navigate it actually becomes insanely complex. So I write a lot of different books. Now, admittedly, part of the reason why I write these books is because I want to democratize access to the future, but also there is so much going on, these are a backup to my brain. So most people basically actually have post-it notes, I have books. Now, just to sort of show you, when we have a look at the trends that we're all being subjected to, that affect us directly or indirectly, this is inevitably what we're trying to get our heads around. So there are hundreds of trends that we've got to try to figure out. What does it mean for us as individuals, our business, our industry, society, at a regional level, at a global level? All these trends are connected. What happens in one industry affects you in your industry. What happens in one part of the world inevitably affects you in your region. But more than that, increasingly, while we're all being subjected to these different trends, we increasingly have science fiction-like technologies right at our fingertips. I mean, if we step back 100, 200 years ago, basically these things that we call lights in the sky would have appeared like magic to most people. let alone electricity and everything else. And yet, now, when we actually have a look at all of the different technologies that we talk about, often we talk about kind of 5 to 10. We kind of talk about things like 3D printing, 5G, artificial intelligence, blockchain, virtual reality, augmented reality, and a few other things. But when we talk about building the future, building the next generation products or services that will either disrupt an industry or make an industry, it's how we combine all these different technologies together that figures out how much is or isn't disrupted. So I'm not going to go through all of these, but basically during this presentation, I'm going to focus more on artificial intelligence, basically within this space. However, when we have a look at things like 3D printing fundamentally disrupts the $10 trillion manufacturing industry. But we had a branch of 3D printing that was innovated on top of to create 3D bioprinting, which means we can 3D print human organs. In Israel, they 3D printed a miniature beating human heart. In 10 years' time, they figure that they'll be able to transplant that heart into a patient. And that patient will come in the morning and leave in the afternoon because it will be made from their own stem cells, so there will be no immunosuppressant drugs needed. When we have a look at things like bioreactors feed the entire planet. I'll talk about that in a little bit. Because you can see there are about 180 emerging technologies on here. Biotech is actually by one of the busiest sectors outside of the energy sector. We've got anti-aging drugs, let's see, which I've been taking myself. I am actually 70. We've got bioelectronic medicine. Now, bioelectronic medicine is already proving to be a superb cure for chronic pain because we put small nanosensors and nano-devices, nanoelectronics onto individual nerves, and we can kill pain in different ways or manage it. The whole conversation itself. Biohybrid organs, when we have a look at the University of Washington, if we can 3D print a human heart, why can't we 3D print a human heart with built-in electronics that figures out that it's beating irregularly and then sends a message to your smartphone that something's amiss, or shocks itself back into life. So when we start talking about living in a world full of science fiction-like technologies, we really are. We've got genetic firewalls, genetic kill switches, hybrid human immune systems. So this is where we're increasingly starting to reprogram the actual human immune system itself. So things like T cells, for example, so that they can proactively go and kill cancer cells. So human hybrid immune systems sound science fiction-like, but we've already proven that they work. Nanomedicine with nanobots, personalized medicine, phage therapy, regenerative medicine. That's it. We take a silk bioreactor filled with progesterone, that's easy for me to say, and we grow frogs' legs back. So we're trying to unlock basically how we actually grow human limbs back. And we're far away from that, but nevertheless, we're taking baby steps in regenerative medicine. But also, when we have a look at regenerative medicine, we're incorporating that into bandages, which increasingly help diabetic patients with ulcers and sores on their feet, for example, heal those wounds 4 to 6 times faster than natural healing. And then we've got synthetic DNA, synthetic proteins. We've got xenotransplantation, which has had its ups and downs in chimeric organizations or organs. But then we've got biological computers. So using CRISPR, which is a gene editing technology, we've managed to turn human liver cells into dual-core computers that run 2 genetic programs and 2 genetic codes. The upshot of that means that we can turn human cells into biological computers that can identify different biomarkers and pathogens in the blood, and then we combine that with biomanufacturing technologies, as companies like Pfizer have, and we can start manufacturing the treatment for those pathogens, for those diseases, in situ in the person's body. So, for example, when we have a look at Parkinson's, we now have biomanufacturing bacteria in a person's gut that manufactures the drug in situ as they need it. So healthcare and biotech is this truly science fiction-like place. And we are only just scratching the surface. We've got biological electronics. When we have a look at artificial intelligence, we're sort of in this state of artificial narrow intelligence at the moment. Baby AI. The AIs that we have today are kind of like the 5-year-old equivalent. There's a lot of legroom that we've got. We've got liquid artificial intelligences that we've already built. AIs that we've already 3D printed. AIs that have already been built out of DNA and solved complex computing problems. So when we think of traditional artificial intelligence in terms of ones and zeros, or quantum artificial intelligence, we are going way beyond that. And these exist. You want to go and prod and poke them? I can show you the people who are making these. But then we've got sensors as well. We've got quantum sensors. The University of Surrey recently created a quantum sensor that lets you read someone's mind from across the room. In their case, they're trying to figure out basically whether those people actually have dementia by reading their individual brain patterns. We've got things like bio-optical sensors developed by companies like MIT, or universities like MIT. Because during COVID, how many of us actually sort of were walking around wondering if we're actually ingesting this virus? A bio-optical sensor on a face mask, when it comes into contact basically with a virus, it glows. So you know you've got a particular virus or you've been exposed to a particular pathogen. So when we have a look at the future of artificial intelligence basically within healthcare, we need sensors. We need ways to collect information from different things and objects and parts of our bodies. And then we kick that back to AI, and then AI gets busy. Now, in terms of embracing your power, no one's ever asked you these 3 questions. No one's ever asked your children these 3 questions. What if the only thing that you had access to was all the world's knowledge? So information plus expertise plus artificial intelligence plus the internet equals knowledge. Google gives you access to information. Layer AI over that, you have access to knowledge. ChatGPT is kind of a good example of that. What would you do with that if you had access to all the world's knowledge? What if you had access to all the world's skills? Now, I know Damien basically is obviously sort of being handed his P45 very soon because we have robo-lawyers coming. And Damien, quite a lot of my clients basically are some of the world's largest law firms. I'll hook you up. Now, when we have a look at artificial intelligence, when artificial intelligence automates a skill or a task or a job, and when we put a nice fancy interface over the top of that, like text to something, suddenly the rest of us who are unskilled in that particular job or profession have access to that skill. So I can go into something like Google Bard and say, create an NDA contract. And it'll say, is this the contract you want? Or create art. And say, is this the art that you want? And say, no, that looks awful. So AI, by automating different jobs and tasks, gives us access to those skills at an individual level. And then what would you do if you could bring your imagination to life? This is more of an entrepreneurial play. But for example, if you don't know how to code, I'll show you how to code in 2 seconds. So you develop your app. Creating things is easier and cheaper than ever before. And if you can execute, by the end of the day, you could have your app in front of 3 billion connected people. So when we talk about new business models, transforming the world at speed, the accelerating rate and pace of change, we live in fundamentally new times that run by new rules. So this is the automation myth. Now, if you listen to the news networks, basically AI is going to do really 2 things for us as a society. It's going to kill us and then automate our jobs, right? Now, it might actually do it in the other order, but we're not sure yet. So AI is indeed the tractor. It's the printing press. It's the loom. But This is a mindset thing. If we know that AI is the tractor, you can either be the out-of-work farmhand, wondering what the heck you do next, or you can be the CEO of John Deere. But society and education today does not teach us how to be the CEO of John Deere. And so most of us are in this place, just stuck, thinking, if my job dead ends, what the heck do I do? Right? Rodents on the treadmill. We have the tools today to make you the CEO of John Deere. We know how to do this. Now, when it comes to ChatGPT, these are some interesting stats. Because, basically, I'm going to give you the real view, not the bullshitty view, excuse my French. ChatGPT has 1% of the connections of the human brain. It has a verbal IQ of 155. These are measured, these are results. That puts it in the top 0.1% of humans for understanding natural language. It contains over 1,000 times more general knowledge than any human brain. 1,000 times. And this is in 2023, not 2024, 2025. Also, because of the way it's been designed, it learns 300 million times faster than the human brain. This, on the one hand, if you listen to the news networks, is your competition. If you listen to me, it's your best friend. Now, this set of stats means that Geoffrey Hinton, who's kind of regarded as the godfather of AI, he recently resigned from Google, says that this is a fundamentally superior learning algorithm because it's got 1,000 times more general knowledge than the human brain, learns 300 million times faster, but in 1% of the connections. Okay? This is sort of what we're up against. Now, when we listen to the news networks, when we listen to the University of Oxford, McKinsey, basically all these other sort of organizations, including OpenAI, AI is coming to partially automate or fully automate 80% of jobs. I was in China about a month ago, and they say 100% of jobs, which I'm not quite sure is 100, but it's certainly probably a bit higher than 80%. I can show you how we can use AI to automate creators and lawyers. We're picking on Damien today, aren't we? It's absolutely clear. That's it. Don't worry, Damien, we've got a way out. Influencers and doctors. Now, half of my family are actually doctors and surgeons. They're sort of ENT, cancer surgeons, and so on and so forth. My mother basically was actually a child's nurse up in university in Birmingham. Doctors are really hard to actually automate. Then there's also the question of just because you could automate things doesn't mean that you should. Because especially in healthcare, you need empathy. Machines basically are crud at empathy. Have you ever seen Pepper the robot basically talking to an elderly person? It's like a toaster basically on wheels, basically trying to actually create empathy basically with, another toaster. Now, when we have a look at this, we kind of have this issue. We've got an accelerating rate of change. We've got possibly some careers that will dead end, but we've got other careers that are upticking. Okay? So for example, if you've got data scientists, I can show you an AI that's doing data science. But then we move to quantum data science, and that's a new job. It's a new skill. So I do a lot of work with universities like Carnegie Mellon, Michigan State, University of Greenwich, all kinds of different ones. I also do a lot of work basically with secondary schools. So using ChatGPT, we've been able to show that you can help people learn 3 times faster. Because if you want to actually go with the rate of change, if change is so fast, we need to upgrade the human learning algorithm, as I call it. We talk about artificial superintelligence. Why don't we talk about human superintelligence? So using ChatGPT, and you can download the codex from here, because actually, since we spoke on the phone, I spent about 2 weeks updating the Future of Education and Learning Codex. We can learn 3 times faster. I'll give you a little example. And we can boost our skills by 30%. Now, in the 1960s, there was this psychologist. He was called Bloom. And basically, he sort of did an experiment. And it's called Bloom's 2 sigma experiment. And he sort of said the basics. He said the obvious. He said, what I've noticed is when we have one teacher for 30 students, the students kind of do all right, but they all come out kind of average. When we have one tutor for one student, so a 1-to-1 ratio, suddenly we get someone who's an expert at something. But he said, and this was the 1960s, but he said, the biggest problem that we've actually got in the 1960s is there is no way to give everybody a one-on-one tutor. So we're kind of stuck. With large language models and AI, we have a way basically to create one-on-one tutors. I've been doing it with my own children. So for example, with my kids, basically if they don't understand a topic, they will go to ChatGPT and say, can you explain this topic? And it'll say, yep, here you go. Can you explain it in the fashion of a 10-year-old? Yeah, when we talk about cancer care, for example, you can ask it and say, I would like to move into cancer care. Can you tell me the hard and soft skills basically that I need to be a cancer carer? And it'll say, well, these are them. Okay. Well, what do I need for each one of these? Give me a detailed breakdown. What do you need this? Create a lesson plan for me. Here's your lesson plan. Now show me all the sources of information that I need to go to or could go to basically to actually learn about cancer care. Here you go. So using ChatGPT and artificial intelligence, basically we can accelerate learning and we can boost skills. And if jobs do dead end, we can move you from this job to this job faster than ever before, and we've done that with Accenture. Accenture made 17,000 positions redundant because they automated them. But they didn't make a single person redundant because they moved everybody to new jobs. New jobs that had been specifically tailored and created for those 17,000 people. So we have a way, basically, to ride the wave. These also democratize access to skills and boost productivity. Now, I'm not a programmer, but last week, or the other week, I was with Visa. In Python, this was the morning, basically, in the Caribbean. I was kind of slow. In Python, write a Stripe integration for Laravel. So this is writing a Stripe payment integration. I'm not a programmer. Hit return. The network over in the Caribbean's a little bit slack. Here you go. Here's the code for a payment integration. So I talk about using these tools to democratize access to skills. I'm not a programmer, but using these tools, I can access the skills of a programmer. And then I say, how would I implement this? Because I'm not a programmer or a coder, and it tells me how to implement it. But you can apply this to any kind of job role, any kind of skill. Which is why I said earlier, what would you do if you had access to every skill? And you can see it's kind of generated everything that we need. And then we execute it and off we go. I've got 8-year-olds who are now coding without ever needing to know how to code. We're generating machine vision applications and all kinds of things. Now, bring it back to healthcare. We sort of think, that AI is a zero-sum game. And this is where I sort of, when I'm talking to leaders, I say you kind of have two options. Most people will say, okay, how do we use these tools to automate large swathes of our workforce? Okay? That's fine. I mean, that's a zero-sum game. You get rid of all your human capital. You get rid of everybody basically that knows how your business works, knows all those client relationships and everything else. You get rid of the people basically that you've invested blood, sweat, and tears in. Or you can augment people. So this is one of the very few studies on what happens when you augment an expert artificial intelligence in radiology with an expert human radiologist. They both did really well independently. They kind of got results basically in the sort of the 85, 90 percentile mark. But when you combined a human expert radiologist with an expert artificial intelligence in radiology, the results were 38% better. So by augmenting ourselves with technology, like we use Google today, everyone finds Google useful, helps us do new things in new ways. You can achieve new levels of productivity. You can do things more. You can do more things better. But trying to augment a workforce is difficult because we're kind of sort of automatically predisposed to do the simple thing. We've also got AIs that are helping humans dominate strategy. In the customer service space, we have AIs that are listening in on calls and saying, this person sounds a little bit agitated. Is a human call center operator just slow down a little bit? Use this language to improve customer service outcomes. So we have AI teaching humans empathy, which I kind of find hilarious. AIs are also helping humans decide. We saw it from Martin earlier. We take huge amounts of information. And because we now have more information, but accurate information, these systems are helping us decide faster about very different things. What market do I move into? What product do I create? What do I do with X, Y, and Z? And as you start being able to talk to these computer systems, conversational artificial intelligence is around the corner. I can say, I've got a problem. Can you help me with the problem? And the AI will say, yep, what's the problem? You've got to be able to talk to the AI and say, this is my issue. And it says, well, have you tried A, B, C, or D? Well, no. Why would I try B? Well, because based on my data, I've got X, Y, and Z. So increasingly, as we start entering a phase of conversational artificial intelligence, we start unlocking all kinds of human potential, all the questions that you wanted to ask but could never find the answers to, all the things that you were curious about. And then from a futures mindset, bringing it to the future, I generally find basically that when people start approaching the age of 50 or 45, someone shall remain nameless. Yeah, there we go. When people start getting close to 50, they start, in their head, they ramp down, right? So I'm 50, I'm 15 years away from retirement, because we typically think of the future in 15-year blocks. If something's less than 15 years out, we start ramping down. Okay? So by the age of 50, from a career perspective, we're going, well, I'm going to retire at 65, so I'm going to start ramping down my career. IBM was trying to get rid of these people basically like crazy, which they went and had a lawsuit on, which is a different story. But what if, rather than retiring at 65, rather than sort of realizing basically that we might actually just die at the standard average age of 84 if we live in the UK, what if we actually managed to live beyond 100, but our health span matched? What would happen basically if you were kind of 80 years old, but still had the body and the mindset of a 35-year-old? At the age of 50, if you could see basically that we had this kind of healthcare actually coming through, the chances are you wouldn't be ramping down at 50. You'd probably be ramping up. And not only does that change your life and your family's lives and your relatives' lives, but that changes everybody's lives around you. So talking about living beyond 100, it's estimated that 2028 is the year that we reach escape velocity, where the number of healthcare innovations and breakthroughs mean that we add more than a year's worth of life for every year that we live, provided you have access to it. Now in the US, that's a challenge. But if you have access to some of the things that I'm going to show you, we can push 100 fairly easily. Now, these are statistics from 2019 from the World Health Organization. They don't incorporate COVID-19 data. But as you can see, over the past 30 years, what we are dying from has changed. So humans are still clumsy. In fact, that's really why we keep getting replaced by robots, if you listen to a lot of the AGM meetings, because we are clumsy. So we are just as clumsy now as we were 30 years ago. So, hey. Communicable diseases, though, have dropped from 44% of the total to 26%. So in other words, we're dying from fewer viruses and bacterial infections and that kind of stuff. Non-communicable stuff, deaths, are actually the thing to go after. So we've switched. This is kind of lifestyle now. But when we actually have a look at what we're kind of dying from, 17 million people a year die from disease, and we've got blood pressure, high blood sugar levels, diet, so lack of diet, pollution, smoking, heat, car accidents, and mental health. So if we're going to live beyond 100, but we're going to do it healthily, so our health span is keeping up with our lifespan, then from an accident perspective, artificial intelligence is helping us in all kinds of weird ways. So when cars start driving themselves, we're at category 3 now, we'll get to category 5 cars in the next about 3 years. This saves 1.2 million people. Okay, so AI plus a car that drives itself saves 1.2 million people from deaths, let alone injuries and everything else. Now, when we have a look at non-communicable diseases, we have ways to make food from air. So 1 billion people on the planet don't have a healthy lifestyle because they don't have enough to eat or have a healthy diet. Using a NASA technology, we can make protein from air. So when we talk about the agricultural sector, there's lots of new food tech coming through because we all know that nutrition is a vital cornerstone, basically, of health. We can produce meat without the animals. Over in Abu Dhabi, basically, we put a cell from a chicken into something called a bioreactor and create chicken nuggets. Don't need the chicken. So when we have a look at the future of agriculture, aka how we produce food, there's a lot going on, which improves our health and wellness. We're electrifying everything. This saves over 6.7 million people. So if you think of the electric cars that you buy that don't pollute, if you think about moving our energy generation systems basically from fossil fuels to renewables, we can save 6.7 million people just there alone. Now in Europe, basically one of the biggest problems that we actually have from a deaths perspective that we see increasing is heat. And this is inevitably what you're going to end up dealing with a lot more, because we'll end up with a lot more elderly people and people who are generally not well, suffering from heat stroke and all that kind of stuff. Now in Miami, basically they just appointed a chief heat officer, and in the construction industry, this is where we are trying to green the cities, because we're trying to cool cities down. But this is an increasing problem. Now when we have a look at the mental health crisis, 1 in 6 people globally now have some form of mental health issue on different levels of severity. With the companies I go into, basically I sort of ask them, say, look, we've been through this entire pandemic. Lots of people have died. How many people have actually had time off just to think about themselves? Because without your mental health, everything else suffers. So how many of you have actually just been completely selfish? Not thought about anyone else, just thought about you and done this?
What do you feel when you say the word I?
Make a choice. Like, you just decide what it's going to be, who you're going to be, how you're going to do it. Just decide. And then from that point, the universe is going to get out your way. It's like it's water. It wants to move and go around stuff, you know.
If you decide to drop your buckets where you are and develop your gifts, I grant you, you'll never ever be without. I grant you that your gifts will take you places that will literally amaze you. So decide that you're going to take some time to work on you, that you deserve that from yourself, that your life deserves some prime time, because you are creating your own production. You are the star of your show. You are the director. You're writing the script. And you will determine whether your life is a smash office hit or flop.
I'm going to work. I'm going to press forward. I'm going to learn. I'm going to do everything in my power. Every single day, I'm going to do everything in my power to become a victor and not a victim. Winners win and losers lose.
First, it's better to be prepared for an opportunity and not have one than to have an opportunity and not be prepared.
So be selfish, take you time. We have AI that's increasingly being incorporated into telepsychiatry services, companies like Wobot, and so on and so forth. When we have a look, basically, at mental health, basically, we have new optogenetic technologies, basically, that actually let us get people to forget that they are addicted. So when we have a look at memory editing technologies and so on and so forth, basically, that is a science fiction area that's already coming through. When we have a look at communicable diseases, basically, quantified self and predictive healthcare, basically, in my estimation, is the way to go. This single slide here would have saved 16 of my friends over the past year, basically, who died from grade 3 and grade 4 cancers, because in my father-in-law's case, basically, he got a little thing through the post from the NHS, basically, when he reached a particular age. He took the test, basically, and actually suddenly discovered he had a grade 3.5 bowel cancer, and a peritoneum cancer. If he'd actually got that earlier, it's highly unlikely he'd have died. So we've seen lots of people die, particularly from cancers, the other big C. Now, when we have a look at things like this, what's this? No. This is a tricorder. If any of you watch science fiction, this is a tricorder. I will explain. So university students around the world basically actually use typically about $50 basically to put these systems together. So, by combining artificial intelligence, basically with the camera, I can use this to detect skin cancer, pancreatic cancer, inherited genetic conditions, and so on and so forth. The blood pressure of my face, the heart rate of my body. I can use the accelerometer plus artificial intelligence, basically in here, and I can predict whether or not I'm going to have a heart attack. I can do the same thing with my smartwatch. However, with artificial intelligence, basically, and the microphone in here, AI can tell whether I have the onset of dementia, PTSD, depression, and everything else. Using other sensors in here, the speed at which I pick my phone up is measured by Facebook, because when you are happy, you pick it up quick. When you're sad or depressed, you pick it up in a different way. The way that you type belays basically actually how emotionally fit you are at that particular time. So AI plus a bog standard smartphone creates a tricorder and helps decentralize, democratize, and demonetize secondary healthcare. And I'm only scratching the surface of what this can do. Stick all that into one app, and you have a tricorder in your hands. And they're all about 97% accurate, by the way. Regulators are trying to get their heads around that. Now, when we have a look at AI plus a smartphone in Africa, we can turn the smartphone into a microscope that in this case helps us detect malaria and tuberculosis within 2 hours as opposed to 2 weeks. So we take a blood sample from people, shine laser light into it, use artificial intelligence and the AI microscope, and suddenly we can identify different pathogens and everything else in the blood. By using artificial intelligence plus a blood test, we can identify fragments of DNA from cancers, and we can predict that you have cancer, or we can show that you have cancer, and we can catch it up to 5 years before you get it. With Parkinson's, we can tell you whether or not you're getting Parkinson's in 15 years' time. So when we have a look at preventative healthcare, I've never been a fan of having a heart attack and then being in a hospital. I've been much more a fan of, you're going to have a heart attack. These are some of the interventions that we're going to do. And if you do still have a heart attack, there's an ambulance already waiting for you with an appropriate EMT crew on board. Out of Australia, we have AIs that take huge volumes of information, so CAT scans, X-rays, PET scans, and all sorts of different things, and actually predict your death day. Because they say people like you, basically with blocked arteries here and a funny lung here, typically live about 3 years. So that's kind of a morbidly humorous use of artificial intelligence, but actually it's proving quite accurate. We're also using this when we talk about heart attacks and everything else. We've got companies like Google DeepMind, basically where the AIs are simulating every single known protein on Earth. This helps accelerate the development of drugs and treatments, basically within the healthcare space, like nobody's business. When we talk about next generation vaccines using artificial intelligence and supercomputers and genome sequencing, we can now make, because we've done it, a vaccine in 7 minutes from scratch. We've also turned vaccines basically into aerosols. We've bioengineered them into plants, basically put them into plasters and chewing gum and everything else. So if you don't actually like needles, we just stick a plaster on you, you now have your vaccine. We've got cancer vaccines that are coming through, especially in China and the US, for particular cancers. Ebola vaccines, and we seem to have some rather promising HIV vaccines coming through. AIs out of the US again, Boston area, have already made new antibiotics which are highly effective. We've got gene editing solutions as well, basically which literally go into resistant bacteria and, like chainsaws, screw up their DNA. Phage therapy, polymers, and synthetic molecules. Synthetic molecules are proving really effective against drug-resistant bacteria. We have companies like In Silico out of Australia with zero-shot learning models where their AIs made 30,000 new drugs in 21 days. Now think about this. This accelerates the drug discovery process, but it lowers the cost. So they had 3 category A drugs out of this, but they also had a long tail of category B and C drugs out of this. Now, if you have a rare disease, most pharmaceutical companies won't go anywhere near it because it costs too much, basically, to go and develop something for a rare disease. By dropping the cost, if you have a rare disease, increasingly, we could likely find a treatment and a cure for you. When we have a look at things like ChatGPT is being reapplied, basically, in the healthcare space. So without skills, soon I will be able to type, I want you to create a drug treatment that binds to a site on a bacteria, site HR2A, and the AI will go off and synthesize and simulate the new drug. So we are really close to the point where researchers can literally type in the kind of drug that they want the AI to go and crunch. Bear in mind, these AIs have access to tens of millions of compounds on the back end. But once we've created our drug treatments, we need to be able to test them quickly to figure out whether they're going to kill somebody or cure somebody. So we have humans on a chip, which is literally you on a stack of chips. Your heart, your brain functions, liver functions, whatever it happens to be. And then we can actually figure out if this actually kills you or not. We also have digital twins. So we're using artificial intelligence, especially basically with the US military, to pull together PET scans, CT scans, X-rays, and everything else into a digital avatar of yourself. And then, once we've got our treatments, we can actually test those treatments on our digital twins, and if they kill you, we just change the formulas, change the treatments, run it another 10,000 times until we don't kill you, or don't kill your digital twin. But this accelerates drug testing like crazy. If you look at the COVID vaccines, it took 3 months to produce the COVID vaccines. It took about 6 months to actually test it. So we're crunching the whole chain. We've already got a company now, basically, that is able to sequence your human genome in the lab, in the hospital, within 5 hours. Personalized healthcare is now starting to get affordable. This is almost at the $100 mark. So if you think about being able to sequence the human genome in about 5 hours, which they did, by the way, for around $100 to $1,000, bear in mind that comes down, this now opens up personalized drugs. When we have a look at in vivo gene editing, we've got CRISPR technologies that we've already used. We had a patient with Hunter's syndrome, put him on a bed, gave him a cup of tea, put him on an IV drip. The CRISPR solution basically went in, clipped out the bad gene, clipped in a new gene. He no longer has Hunter's syndrome. So if you're born with an inherited genetic condition, increasingly, we have a way to actually tentatively cure you. But all of these are in progress. We've got cancer therapies that are 100% effective, 100% effective. Personalized cancer treatments, basically, that are coded to the DNA and the cellular structure of the cancers themselves, particularly bowel cancers and everything else, 100% effective. Designer humans. We've got universal organs, basically, that are now starting to come through as well. We don't have to wait for a specific transplant. We've got 3D printed medicines because we all take the same kind of dosages, even though we're all different. And these medicines are increasingly designed by artificial intelligence, basically, so that we can personalize them to you. You can either print them in the hospital, which collapses the hospital's entire drug supply chain, or you could print them at home, if you had a 3D printer or the right 3D printer. We've got 4D printed hybrid organs. Now, we've got 3D printed organs, which you can implant typically into adults. So bones, skin, tissue, that kind of stuff. 4D printed organs move that forward because you can put a 4D printed heart into a child, but the difference between a 3D printed heart and a 4D printed heart is the 4D printed heart grows with the child. A 3D printed one doesn't, which would be a bit of a problem when we talk about children. And then, rounding it off, if you do die, increasingly we have companies basically like Soul Machines. There are 5 Fortune 100 CEOs that are now immortalizing themselves as digital avatars. So that when they die, their grandkids can go, "Granddad, when you were the CEO of Unilever and you were opposed basically with a merger and acquisitions debacle, what would you have done?" "Oh, well, I'd have done this." Gone on holiday. So increasingly, we have tools that let us immortalize ourselves in artificial intelligence, digital human form. And that's before we get anywhere near all of the other amazing healthcare technologies that are actually here today in the labs and coming out of the labs. So thank you very much for your attention. I hope you enjoyed a little trip into the future. And there we go. Thank you.